Okay, so we've taken a look at solving systems of equations graphically. We're now going to take a look at algebraically. Now, you already covered this topic in Math 10 using linear systems. We're now going to take a look at linear and quadratic and quadratic and quadratic. And if you recall from last year, where there were two ways or two methods that you could use to solve algebraically. One was by substitution and the second one was by elimination. So we'll take a look at substitution first. And we have a rather simple one set up for you. If you notice, we have y equals and y equals, so we've already isolated our y's. This makes substitution very simple. When you have a situation like this, then all you want to do is equate your two y's and then solve for your x. Okay? So that means we want to take the 2x minus 2 and the x squared minus 6, and we want to make them equal to each other because we want to set our two y's equal to each other. So we want to say that 2x minus 2 is equal to x squared minus x minus 6. Now, why can we call this substitution? Well, if y is 2x minus 2 and y is x squared minus x minus 6, we could take this y value and just plug it into this y value, okay, which is why we can say that we will equate our two y's together. Okay, so notice you now have an equation which you can see is going to be quadratic because you have an x squared term. So when we have a quadratic, we want to set everything equal to 0. So we're going to go 0 equals x squared, and we're going to bring our 2x over to the right. When we do, it'll become negative, and so negative 2x minus x is negative 3x. And we will take our negative 2, bring it over to the right. It becomes positive, so we have negative 6 plus 2, and we get negative 4. Okay, and then you have a variety of ways that you can solve your quadratic. You can solve by factoring if factoring is possible. You can use completing the square. You can use your quadratic formula. Okay, any of those ways. You can graph if you want. Okay, but this one factors, so my two factors of negative 4, that will add to give me negative 3 or negative 4 and 1. So I'm going to go x minus 4 and x plus 1. And then I can see from this that one of my factors, if I set it equal to 0, will give me a value of 4 for x. And my second factor, when I set it to equal to 0, will give me a value of negative 1 for x. And so you can see that we have two x values. Okay, so probably what that means is we're going to have 2 points of intersection. So what we want to do now is find out what our value for y is when x is 4 and what our value for y is when x is equal to negative 1. So our next step is to find y. Okay, now I can find y by either substituting x into my linear function, 2x minus 2, or I could, if I wanted to, plug in my x value into my quadratic function, x squared minus x plus minus 6. But probably you've already decided it would be a little easier to plug it into my linear function. I don't have to worry about squaring any numbers, and plus I only have 2 terms here versus 3 here. Okay, so I'm going to find y when x is equal to 4. I'm going to plug it into my linear function, so I'm going to go 2 times 4 minus 2, that's going to give me 8 minus 2, which is 6. Okay, and so when x is 4, y is 6, and so one point of intersection is at 4 and 6. Okay, so we had one x value of 4, which we plugged into here, and so our x coordinate is 4. And I wanted to find y, and so my y coordinate is 6. Okay, and let's find out what y is when x equals negative 1. And once again, I'm going to plug it into my linear function because it's easier to do that. And so I go y is equal to 2 times negative 1 minus 2 and I get negative 2 minus 2, so I get that y equals negative 4. And so I have another point of intersection where x equals negative 1 and y is equal to negative 4. Okay, so x equals negative 1, plug that in. It's the x coordinate to my solution. And I found that y is negative 4, and that's the y coordinate to my solution. Okay, and as always, you should verify your answers. Okay, these points of intersection should be solutions, or yeah, for both equations. Okay, so let's work with 4 and 6. Plug it into our linear function. So 6 equals 2 times 4 minus 2, and I get that 6 equals 8 minus 2, which is 6, so that works. Plug it into our quadratic. Y is 6, x is 4. And I get 16 minus 4 is 12, and 12 minus 6 is 6, so that works. So let's check our point negative 1 and negative 4. Our linear function, 2x minus 2, y is negative 4. And I get negative 4 equals negative 4. And my quadratic, y equals negative 4, negative 1 squared minus negative 1 minus 6, so negative 4 equals negative 1 squared is 1, minus negative 1 is 1, so I'm going to have 1 plus 1 is 2, 2 minus 6 is negative 4, and so that works too. And so these solutions are 4 and 6. And negative 1 and negative 4. Okay, now something else to note. When you have two solutions, so two solutions, you will have 2 points of intersection if you were to graph those two functions. So two solutions means 2 points of intersection. Okay, if you had two systems where you would have no solution, then if you were to graph them, you would have no points of intersection. And if you were to work it out algebraically and find that you only get one solution, then if you were to graph it, you would have only 1 point of intersection. Okay. What if the y's are not isolated? So for example, we've got 5x minus y equals 10 and x squared plus x minus 2y equals 0. Well, no panicking here because you can isolate y, right? Now, in this particular case, because really you don't always have to isolate for your y's, sometimes it makes more sense to isolate for x. Okay, and I'll explain what that means. If we just take a look at our linear function here, and we've got 5x minus y equals 10. Let's say I want to isolate for x. Well, that means that I'm going to move the y over, it becomes positive. And then I have to divide by 5, and I get x equals y plus 10 over 5, which would get really messy if I had to substitute into x squared over here. Okay? The y makes more sense. Okay, so I'll do the same thing. Let's isolate for y this time. So we've got 5x minus y equals 10. So negative y equals negative 5x plus 10. Don't want negative y, so you want to multiply everything through by negative 1. That gives you y equals 5x minus 10. This expression, okay, 5x minus 10, is going to be a lot easier to work out when you plug that into x squared. Okay, but just remember what I said. Sometimes it's not going to make any sense to isolate for y. Sometimes it will make sense to isolate for x. Okay? And when would that happen? Well, if x has a coefficient of 1 and y doesn't. All right? Okay, so now we've isolated for y, so we can take this equation. We wrote it as y equals 5x minus 10. So we want to take this and we want to plug it into y over here. Okay, so we want to take that and plug it into there. So we're going to have x squared plus x minus 2 times 5x minus 10 equals 0. You're going to distribute the negative 2. And so you're going to get negative 10x, and negative 2 times negative 10 is positive 20 equals 0. And notice it's quadratic, so combine your like terms. You're going to have x minus 10x, which is negative 9x, plus 20 equals 0. And you're ready to solve, so you can use factoring if it's factorable, quadratic formula, and so on. This one's factorable. So the factors of 20, that will give me 9, negative 9, or negative 5 and negative 4. So we get x minus 5, x minus 4, and I'll just finish off over here. So you will get that x is equal to 5 and x is equal to 4. And we now want to find out what our y coordinates are. And once again, it's going to be easier for you to plug that into your linear function than it is to plug it into your quadratic. And because we already have y isolated over here, we're going to use that. So the first one, we're going to plug 5 in for x. So we're going to get y equals 5 times 5 minus 10. So we get 25 minus 10, which is 15. So we have one point of intersection at 5 and 15. And then we're going to plug in 4. So we go 5 times 4 minus 10. That gives us 20 minus 10, which is 10. And so our second point of intersection is where x is 4 and y is 10. And so these solutions are 5 and 15 and 4 and 10. Okay, and because we don't have a lot of room here, we can't verify, but you should really verify. Okay, and the next video will take us into example number 2.